Hello friends, in this video we will learn the concept of ownership inside the Rust. So what is actually a ownership, right? Ownership is a set of rules that governs how the Rust program manages memory. So all the programs have to manage their way they use the computer memory while running. Now the some languages have the garbage collection that regularly looks for no longer used memory as the program runs. In the other language, program must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through the system of ownership with the set of rules that the compiler checks. Okay, so ownership is a really new concept. Now, before learning the ownership, we have to learn the concept of stack and heap. So the majority of the programming languages, because all the programming languages, not majority, basically stored either in stack or in a heap. Let's try to understand this. I am opening paint. Okay, so let's suppose we have this one. This is your stack, right? This is your stack. The stack, each of the like a variable, suppose we have the variable hello, right? This variable is fixed of fixed length, right, of 5 characters. Total character is 5, so the length will be that will be length. So in the stack, how we will just go, it will just h, it will just insert h. Okay, then it will insert e, then l, then l, then o. Or and while printing, it will just first whatever the inserted in the last, it will just come out first. So last in first out is the concept of stack, right? Whereas in the heap is like a space. This is the space. Okay, so in the heap, the variable is stored could be like anywhere from here in the table or here, wherever the space is sufficient to store that variable. Means heap should be large enough to store 5 variable. Okay, so this is how stack and heap works. So both allocate memory, right? So X stack is generally used for fixed values, and the heap is generally used for runtime, because at the runtime we don't know the actual size of the characters which the user will give program. So the this heap has a variable size, yeah, based on the free memory. Heap can be large or short based on the memory which is free, okay, inside the program. So at the runtime, generally at the stack, it stores a table that contains a reference pointer to heap, and the actual values are stored inside the heap. Okay, so this is how generally the program uses heap and stack to manage its variables or the memory. Okay, now we have the role of ownership, variable scope. So we have to learn the scope of the variable, right? So we have, like, suppose we have main program int main. It's a C program int main, like, and we have some variable x here. Suppose we have variable x. So scope of the variable will be up to the starting from the initialization of the variable till end of the class or the function. So this is the concept which is followed. So scope of the variable will be up to the class or object which in which the variable is initialized. Okay, now we have, suppose we have the variable scope we have given, this is the constant term, right? It will allocate a fixed amount of memory. Now for the demonstration of the heap, we cannot directly use the simple string. We have to special function of the string which is let s dot form. Let s is equals to string double colon, and then we have from hello. So it will just allocate the hello inside the heap memory, right? Let's write this. Okay, let's create a file new, and we don't want to save it. We have let, can you increase the size a little bit? Let x is equals to string from hello. So what it's doing is, let we are creating a variable of name x that will be of type string. We are not specifying the type here. We are having the string from hello. So we are allocating the hello into the heap. Okay. So we have also, I think we have that also table also. Okay, where is the table? Here. Here for this one, program is a little bit different. We have s1 and we have s2. Okay, let's try to understand it. So here it's creating a table while x. Okay, now I am allocating a variable x1. Okay, this, let's suppose this is x1, and now we have x2 is equals to x1. So what we are having a problem here. What is the problem? We will look into that and we'll try to understand the concept of ownership now. So what this function will do, what this line will do, it will just create a table. Okay, and this table will have, I think, three values: name, okay, parameter, length, and capacity. So it will have a parameter, sorry, pointer, length, and capacity. Okay, pointer is like the table. We have now the another table. Okay, we are table. Okay, we have the table. We have, this will be a pointer, and this will have a value, and this will have a name, this will have a value, right? Pointer is 0, 1, 2, 3, 4, total 5, and this will contain value h, e, l, o. Okay, we have this type. So it will contain the pointer location of this one, and we have length, total length will be 5. The capacity could be 6 or could be 7, but we generally allocate the heap as of size of the length to minimize the usage. We can, capacity could be bigger to just store more large variables or more large values, but for here we are just assuming it's 5. Okay, what it's doing, when we are writing it, it's just creating a table, and this pointer is just referencing to the another table in the heap which contains the value, right? So when we were trying to like, so when we were trying to like allocate the x2 is equal to x1, so this table, this is the values table, is having the ownership, owner, this is the owner, right? So this is the owner having owning this values. So when we allocate, try to allocate like x2 is equal to x1, it will just create another table. This is the table for x1, this will be the table for x2, and it will have the same pointer and length, and then we have capacity. The pointer will again just reference to the same place because we are just allocating it, right? And the length will be 5 and the capacity will be also 5. So whenever we now try to delete, if we just command take the delete, delete to x1, the delete function will just try to delete this table, this one, and its reference, this table. Now as the table is deleted, this one table is also deleted, right? This table is also, this pointer is also referencing to the same table, so it will just result in an error because this is deleted and the same thing is referencing this, right? So this is the error that generally we face. So this is called the ownership, right? So this table is owned by this. It cannot be owned by another variable, because if we just try to allocate the same table with the again different thing, it will just, if we delete the second thing or the first thing, it will just create error for the other values or another references. Like we have deleted the x1 and we deleted the tables, so it will just create well error for like x2. Okay, now that's the same thing. Now we have, so what we actually wanted to do is this. Yeah. Okay, this is the table we have. The same thing we this is the generally we use, like we want to make the table, our table, like this. The reference table should always be different. Like this, we have the index and value. This table should be referencing to s1, and the s2 should be referencing to a different table, not the same table. So if we delete the like s2, it will delete this table, and if we delete the s1, and that will delete this table. So s1 will not affect s2, right? Now to achieve this, I think that is the like copy function. Okay, copy macro, I think. Okay, I think that we will learn in later. Okay, we have the error because we have used the same variable. This is the general error we are going to see. So you can see we are having the like memory after s1 being invalidated. Okay, so scope of the argument. Okay, this is the another things that we need to check, that if we are allocating the value like x, we have a previous value. Let's create, we have a table, right? We have a ptr, this is for x1. We have a pointer, then we have length, we have a capacity, that will be 5 5, and we have a word hello, 0 1 2 3 4, right? We have a table pointer allocating to this value. Okay, now when we try to like again allocate the value of x1, so how we are doing, like what was the code? Let x1 is equals to string from hello, right? Hello, this was the code. Now we allocate the value of x1 again. X1 is equals to string st, string from wl, well, let's suppose well. So well, this will be stored in another table, right? This was the table before, and the next we have x1 will be like the same pointer. We have ptr and we have length and then we have capacity. It will just allocate it to like well, 0 1 2 wel, right? It will just change from hello to this one, and this table, this EC scope will be like over and not valid. So whenever next time we will just call x1, it will just return well, not the hello word. Okay, that's the concept. So that's the ownership will be like changed. We have variable and data interaction with clone. Okay, we are using clone. So in the previous when we showed that how we will just use it, we have this pointer, we are referencing to one table, right? Having this like HOLLO. Okay, so it's referencing to this one, and having this variable, this table is allocated to x1. We want to like, we have given like x1 is equal, x2 is equal to x1. It will give the error. So how we can just resolve it? So we can use the word clone. Okay, if we use the word clone, it will just create the x2. Instead of just having the pointer referencing to this, it will not reference to this. Instead, it will just reference and create the same table. Copy of same, copy of same table will be created. Okay, here, and x2 will reference to that. So in this case, if we delete the x1, the x2 will no effect on x2. Okay, so that's how we use clone. So that's all for like return values of the scope. This is how we just return values from the function. Okay, so we probably give the reference or the borrowing concept of borrowing that we will see in the next video. Hopefully this is how ownership works in the Rust. So if we create a variable or allocate something to a variable, the value or the scope of the variable will remain valid, or the value will remain valid until inside the that variable is used or initialized inside the function. That function is the boundary for that variable. So if we're calling a different function, that's the concept of borrowing. So that's how works memory works. So if we have initialized a variable having from hello, then this is how we change it using clone, and we can just use allocate to a different variable. So x1 will be the owner of this, and this thing, if we just have the x2 is equal to x1, this will be like invalid, because x1 is the owner and x2 cannot just directly take the ownership. A pointer cannot be directly reference to the variable of x1. Okay, I think that's what is written here, and I understood this much only. So if you have any more understanding or any deep values or things to share, please you can write in comment. Thank you so much. The next video we will just go through the reference and borrowing.